Okay, what we're doing today is just a continuation of what we've done the last couple of days. It's a little confusing to just do in writing, so I want to be able to verbally explain some stuff. I have 2 pages of notes and some examples that you're going to do as we work through them, and some problems at the end as well. Okay, first of all, there are 2 things called permutations and combinations. Permutations are when the order does matter. Okay, who finished first, second, third in the race? I'm picking 3 specific things, and the order I pick those 3 in matter. Combinations are when order does not matter. Okay, so a combination would be, hey, I just want to pick 3 people. I don't care if I pick Blake first and then Wyatt and then Bryce, or if I pick Bryce, then Wyatt, then Blake. Okay, it doesn't matter what 3 orders I pick them in. I just want to pick 3 people. I just want 3 people to go help me do something. Okay, so permutations are when order matters. I try to put the O and the P together. Okay, so OP is right next to each other in the alphabet. So permutations are when order does matter. Combinations does not matter. Okay, there are buttons on your calculator that do permutations and combinations. I will show you that in a minute. Okay, the buttons on the calculator will help you do these, but because I'm looking more for, hey, just understanding how to do it, I want you to do it both on your calculator and set it up normal. Okay, example 1, job applications. There are 10 applicants, and your boss needs to pick 3. They're the same job description, so the order doesn't matter. I just want to pick 3 people to do the job, so it doesn't matter what order I pick them in. So it's called a combination since the order doesn't matter. The description, or how to write it, is 10 combinations, pick 3. So the total goes here, and how many you want goes there. So 10 combinations, pick 3. Some of you might have a fancier calculator that does the C and then the 10, 3. But my calculator does it this way. Okay, and that is 120 combinations. I want to show you how to input that in your calculator, or show you what button you're looking for. On my calculator, it's actually right here. The CNR button or the PNR button. C is for combinations, the P is for permutations. Okay. There are other calculators where it's on the statistical thing. Sometimes at the bottom of this one, I think. Yep. Okay. This one is the same as mine, but it's the brown button on both of these 2 right here. Okay. So you'd have to use the shift button to get to them. Okay. There are other calculators. It's part of the probability, PROB. And when you push the PROB, there will be some stuff up here on your screen that show up. Okay, so I want to do 10 total combinations, pick 3. Okay, so the way you do it on mine, you push the 10 in first. Then you push the C button, and then we want 3 of them. So there's your 10C3. Push equals, and it's 120. Okay, so that's how you use your calculator to do combinations, but I want you to be able to do it logically as well, because if you're having a conversation with someone and you don't have your calculator around, I want to make sure you understand how to do it. Okay, first, the logic of how you do it by hand. When the boss is looking at the applications, he has 10 applicants to choose from, just like running a race. He picks 1. Okay? So he has 10 choices. He picks 1. Now he's got to pick another one, but he only has 9 choices left of those applications. So he has 9 choices for the second position. He picks 1. Well, now there's 8 more applicants to choose from for the third position. So it's just like we did yesterday, 10 times 9 times 8. That's 720 ways. But that's if the order mattered, there would be 720 options. Okay? If the order does not matter, then we've got to get rid of the duplicates. Okay, 720 is too many. So the way you get rid of it is I did the logic here, but since it does not matter what order he picked the three people, you need to get rid of duplicates. To do this, we divide. And basically, the shortcut is, if you're picking three people, you need to divide by 3 times 2 times 1. Okay? If you're picking 5 people, then you would divide by 5 times 4 times 3 times 2 times 1. Okay? So the logic of the setup is 10 options, 9 options, 8 options. But to get rid of duplicates, I divide by 3, 2, 1. So it's 720 divided by 6, and that's how you get the 120 different ways. Okay? So it's 10 times 9 times 8 if order mattered. Since order doesn't matter, I get rid of the duplicates by dividing by 3, 2, 1. Okay? And the logic of this is, I put over here order versus no order. Okay? If I picked Grace, then Bryce, then Ethan, and then Grace, Ethan, Bryce, and then Bryce, Ethan, Grace, and then Bryce, Grace, Ethan, etc., that's a lot of different people, different orders of picking people, but they're still the same 3 employees. Okay, they're still the same 3. So we have a lot of duplicates we got to get rid of, and you get rid of those duplicates by doing 3 times 2 times 1. If there were 4 workers, you would divide by 4, 3, 2, 1. Okay, hope that explanation kind of helps. An English teacher. The teacher is going to give you an assignment, and she gives you a list of 15 books to read, and you have to pick 4. Let's say you're doing 1 every 9 weeks. Okay. First thing you got to ask yourself is, does the order you pick the books matter? Okay. If I pick book A first 9 weeks versus picking book A third 9 weeks, does that matter? No, it does not. Okay. The order does not matter for picking the book. Okay. If you pick book A, B, C, D, first 9 weeks, second 9 weeks, third 9 weeks, fourth 9 weeks, is that the same as picking B, A, C, D? That is still the same 4 book reports. So you can't repeat those books. That would be doing the same books 2 different ways. So therefore, we want to get rid of the duplicates. Therefore, it's a combination. So we want 15 total options, pick 4. So 15C4. Okay, on your calculator, that would be 15 combinations, pick 4. That would be 1,365 combinations. Okay. To do it by hand, okay, I have 15 to choose at the very beginning of the list. I do a book report first 9 weeks. Now, second 9 weeks, since I can't do the same book again, I have 14 to choose from. Then I have 13 third 9 weeks to choose from. And then the last 9 weeks, I have 12 to choose from. So it's 15 times 14 times 13 times 12. If order mattered, that would be it. But since I need to get rid of duplicates, I want to divide by 4, 3, 2, 1. 4 times 3 times 2 times 1. Okay. If order mattered, there would be 32,760. But since the order doesn't matter, you get rid of duplicates by dividing by 4, 3, 2, 1 or dividing by 24. And that's how you get the answer of 1365. Okay? So if ordered mattered, it would just be 15 times 14 times 13 times 12, and the answer would have been 32,760. But since I got to get rid of those duplicate books, I can't, what if I do book A and then book B and then book B, book A, that's still the same 2 book reports. I get rid of the duplicates. Since there's 4 books, I divide by 4 times 3 times 2 times 1. Okay. I'll try to do another example to help you. Lottery. Okay. You guys are getting to the age where you might do a lottery. I hope not. You'll see why here in a moment. Okay. You have 6 numbers to pick, and you have 50 numbers. The lottery, let's say there's 50 balls to pick or 50 numbers to pick, lottery balls. and you got to pick the right 6 numbers. Okay? Does the order you pick those matter? For example, if you pick 49 first, but the computer has 49 later, is that still picking the same number? Yes, it is. Okay, so the order you pick them in doesn't matter. Okay, is 3, 12, 38, 45, 48, 49 the same as 12, 38, 49, 48, 3, and 45? Are those the same numbers? Yes, they are. So it doesn't matter what order you pick a lottery in. So therefore, it's a combination. Okay, order doesn't matter. So I have 50 options, and I'm choosing 6. You would have 15,890,700 different combinations of picking 50 lottery balls. Okay? You have 15 million options, or if you think of it as probability, you have a 1 in 15 million chance of winning, almost 16 million chance. Now, by hand, the setup is this. You have 50 choices on the first number. Let's say you pick one. Now you have 49 choices on the second one, 48 choices on the third one, 47 on the fourth one, 46 on the fifth one, and then these 6 numbers, the 6th number, you would have 45 options. Okay? Well, because we have duplicates of 6 numbers, you would divide by 6, 5, 4, 3, 2, 1. Okay? You would have a huge number. I couldn't even write it on here. 50 times 49 times 48 times 47 times 46 is a massive number. But to get rid of the duplicates, I would divide by 720, and that would give you an answer of 15,890,700. Okay, I'm going to do a second video, since this is already at 12 minutes, to do page 2.